Hello there, and welcome. Tonight I want to take you somewhere very special, somewhere far beyond the boundaries of our small blue world, beyond the familiar glow of our sun, out into the vast and quiet darkness where ancient stars are preparing for their final, most beautiful transformation. I want you to settle in now, wherever you are, perhaps beneath warm blankets, perhaps with your head resting gently on a soft pillow, and I want you to let your breathing slow. Let your shoulders relax, let the weight of the day begin to drift away from you like dust scattered on a gentle cosmic wind. Because tonight, we're going to witness something extraordinary together. We're going to travel to the edges of stellar life itself, to meet the red giants, those magnificent swollen crimson suns that have burned for billions of years, and now find themselves approaching the most tender, most mysterious moment of their existence. And as we journey together through this quiet cosmos, as we explore the secrets these dying stars have kept hidden for so long, I hope you will find yourself drifting into a peaceful state of wonder, a state where curiosity and calm exist together in perfect harmony, where the mysteries of the universe become not sources of anxiety, but gentle companions for your journey into sleep. Before we begin this cosmic voyage together, I want to ask you something. If you love these journeys through the stars, if you find comfort in exploring the mysteries of the universe as you drift toward dreams, please consider pressing that like button and subscribing to join our community of cosmic dreamers. And I would love to know, where are you watching from tonight? What time is it there as you settle in beneath the stars? Leave a comment below and let me know, because there is something beautiful about knowing that people all around this small planet are looking up at the same sky, wondering about the same mysteries, finding peace in the same ancient starlight. We are all connected, you and I, and everyone who has ever gazed upward and wondered what secrets the cosmos might be keeping from us. Now, let me ask you something. Have you ever wondered what happens to a star when it grows old? Have you ever looked up at the night sky, at those countless points of light scattered across the darkness, and considered that each one of them is on a journey that began in cosmic nurseries billions of years ago, and will eventually end in ways both spectacular and gentle? It is a question that perhaps seems simple at first, maybe even a question you have never thought to ask, but it is a question that has occupied the minds of astronomers for generations, and it is a question that has recently revealed an answer so beautiful, so poetic, that it feels less like scientific discovery and more like the universe whispering one of its most intimate secrets directly into our waiting ears. You see, scientists have finally discovered why red giants dim their light before death, and the answer is not what anyone expected. It is not a story of violent collapse or catastrophic explosion. Instead, it is a story of gentle transformation, of cosmic breath, of stars slowly wrapping themselves in veils of their own creation as they prepare to become something entirely new. What if, just maybe, the dimming of these ancient stars was not a sign of weakness or failure, but rather the most graceful act of surrender in the entire universe? What if these stellar elders, having burned for longer than our minds can truly comprehend, were teaching us something profound about endings and beginnings, about letting go and becoming something new? Tonight, we're going to explore this possibility together, and I promise you, what we discover will fill you with a sense of wonder so deep, so peaceful, that it will carry you gently into the most restful sleep you've had in a very long time. Let us begin by considering our own sun, that familiar yellow star that rises each morning and sets each evening, that warms our faces and makes life possible on this small rocky world we call home. Our sun is middle-aged now, about 4.5 billion years old, burning steadily and reliably as it has done since long before the first life stirred in Earth's ancient oceans. But our sun will not burn forever. Nothing in the universe burns forever. In another 5 billion years or so, our sun will begin to change. It will swell outward, growing larger and larger, its surface cooling from bright yellow to deep, warm red. It will become what astronomers call a red giant, a star in the twilight of its existence, a stellar elder preparing for the final chapters of its cosmic story. And when that happens, when our sun joins the ranks of these magnificent crimson giants, it too will begin to dim in mysterious ways, breathing out clouds of dust that will veil its ancient light, transforming itself in ways that scientists are only now beginning to understand. but we do not need to wait 5 billion years to witness this transformation. All we need to do is look up at the night sky, where red giants are scattered throughout our galaxy like glowing embers in a vast cosmic fireplace. Some of them are close enough that we can see them with our naked eyes, familiar stars that our ancestors knew by name, stars that have been companions to humanity for as long as we have been gazing upward and wondering about our place in the universe. And these stars, these ancient swollen crimson suns, have been keeping a secret from us, a secret that astronomers have puzzled over for decades, a secret that has finally been revealed through patient observation and careful study. Before they die, these red giants dim their light. They grow fainter and fainter, not suddenly, not dramatically, but slowly, gently, like a candle flame lowering itself in a quiet room. And for the longest time, no one could explain why. Consider the vastness of the cosmos for a moment, if you will. Let your mind expand outward from this small room where you rest, outward from this small planet, outward from this small solar system, outward into the incomprehensible depths of interstellar space. Our galaxy alone contains somewhere between 100 billion and 400 billion stars, each one a sun in its own right, each one on its own journey through existence. And scattered among these countless stars are the red giants. Perhaps 10% of all the stars we can see, each one a stellar elder in the final stages of its life. Some of them are so large that if you place them where our sun sits, their surfaces would extend past the orbit of Mars, past the orbit of Jupiter, perhaps even past the orbit of Saturn. They are truly giants in every sense of the word, vast spheres of glowing plasma that dwarf everything we know in our small corner of the universe. And yet, despite their enormous size, despite their ancient age and their incredible power, these red giants grow quiet as they approach their end. They do not rage against the dying of their light. They do not burn brighter in defiance of their fate. Instead, they grow gentle. They grow dim. They begin to fade in ways that seem almost intentional, almost peaceful, as if they have accepted what is coming and are preparing themselves for the transformation that awaits. This dimming has puzzled astronomers for generations. It seemed to contradict what we knew about stellar physics. Stars are supposed to burn according to predictable rules, their brightness determined by their mass and their temperature and their distance from us. But red giants, in their final years, break these rules. They flicker and fade in ways that cannot be explained by simple physics alone. Something else is happening. Something mysterious, something beautiful, and scientists have spent decades trying to understand what it might be. Perhaps you're lying there now, your eyes growing heavy, your breathing slow and steady, and you are wondering why any of this matters. Why should we care about the dimming of distant stars? Why should we spend our precious hours of wakefulness thinking about the deaths of suns that are so far away we will never visit them, so ancient that they were burning long before our species existed? And the answer, I think, is that we are connected to these stars in ways that are both literal and profound. The atoms in your body, the carbon in your cells, the oxygen you breathe, the iron in your blood, all of these were forged in the hearts of stars like the ones we're discussing tonight. When red giants dim and fade and eventually release their outer layers into the cosmos, they are scattering the building blocks of life across the universe. They are seeding the void with the raw materials for future planets, future oceans, future beings who will one day look up at their own night sky and wonder about their own place in the cosmic story. We are, quite literally, made of stardust. This is not poetry, though it sounds like poetry. This is not metaphor, though it functions like metaphor. This is simple, beautiful, scientific fact. The heavier elements in your body could not have formed in the Big Bang. They could only have been created in the nuclear furnaces of stellar cores, and they could only have been released into the universe through the deaths of stars. When you look at a red giant dimming in the night sky, you're looking at a process that has made your existence possible. You're witnessing the same kind of cosmic transformation that billions of years ago scattered the atoms that would eventually become you across this corner of the Milky Way. There is something deeply moving about this connection, something that transcends the boundaries between scientific understanding and spiritual wonder. We are not separate from the cosmos. We are expressions of it, temporary arrangements of ancient matter that has been cycling through stars and planets and life forms for billions upon billions of years. And so tonight, as we explore the mystery of why red giants dim before their death, We're not merely satisfying idle curiosity. We're engaging in a profound meditation on transformation, on connection, on the beautiful and terrible truth that nothing in the universe lasts forever, but everything in the universe becomes something new. The red giants are teaching us something about endings, about how to approach the close of a chapter with grace and dignity, about how to release what we have been so that we might become what we are meant to be. And perhaps, as you listen to these words, as your mind drifts through the cosmic darkness towards sleep, you will find comfort in this teaching. Perhaps you will feel, as I often do, that there is something deeply reassuring about a universe where even the deaths of stars are beautiful, where even the endings are beginnings in disguise. Let us travel now to one of these red giants, not literally of course, but in our imagination, in that vast inner space where anything is possible, and distance means nothing at all. Imagine yourself drifting through the void, surrounded by the soft glow of distant stars, moving toward a particular point of light that grows larger and larger as you approach. This is a red giant, perhaps 100 times larger than our sun, its surface a deep, warm crimson that seems to pulse and shift as you draw closer. You can feel the gentle warmth of it, even from millions of miles away, a warmth that is different from the harsh yellow heat of younger stars, softer somehow, more diffuse, like the warmth of embers rather than flames. This star has been burning for billions of years. It has witnessed the formation and destruction of countless planets. It has sent its light out into the universe for eons, and that light has travelled across incomprehensible distances to reach the eyes of beings who would not exist for billions of years after it began its journey. And now, as you float there in the cosmic silence watching this ancient sun, you notice something strange. The light is not steady. It flickers and dims, grows brighter for a moment, then fades again. It is as if the star is breathing, as if it is exhaling something into the void that partially obscures its own radiance. And in a sense, this is exactly what is happening. The red giant is breathing. It is releasing material from its outer layers, clouds of gas and dust that drift outward into space, forming a halo around the star that filters and dims its light. This is the secret that astronomers have discovered, the answer to the mystery that has puzzled them for so long. Red giants dim because they are exhaling, because they are releasing parts of themselves into the cosmos, because they are beginning the slow and beautiful process of transformation that will eventually scatter their remains across light years of space. But I'm getting ahead of myself. We have much to explore together, and the night is long and there is no need to rush. Let us return to the beginning, to the fundamental question of what a red giant actually is and how it comes to be. Because to truly understand why these stars dim before their death, we must first understand their life, the journey that brought them to this point, the billions of years of burning and shining that preceded this final, gentle transformation. And so I invite you to settle in even more deeply, to let your body sink into whatever surface supports you, to let your mind open to the vast timescales and distances we're about to explore. We are going to trace the life of a star from its birth in a cosmic nursery to its death in a cloud of scattered dust, and along the way, we're going to discover some of the most beautiful truths about the universe we inhabit. Stars are born in clouds of gas and dust called nebulae, vast structures that drift through the galaxy like cosmic weather systems, their interiors dark and cold and waiting. These nebulae are mostly hydrogen, the simplest and most abundant element in the universe, but they also contain traces of heavier elements, elements that were created in previous generations of stars and scattered into space when those stars died. In a sense, every star that forms is built from the remains of stars that came before it, a beautiful cycle of death and rebirth that has been continuing since the first stars ignited in the early universe, perhaps 13 billion years ago. When a region of a nebula becomes dense enough, when gravity begins to pull the gas and dust inward, a protostar forms at the center, a dense, hot sphere that is not yet a true star but is on its way to becoming one. This process takes millions of years, a time span that seems impossibly long to us but is merely a moment in cosmic terms. The protostar grows hotter and denser as more material falls onto it, and eventually, when the temperature and pressure at its core reach a critical threshold, something miraculous happens. Hydrogen atoms begin to fuse together, forming helium and releasing enormous amounts of energy in the process. This is nuclear fusion, the same process that powers hydrogen bombs, but occurring on a scale so vast that it defies comprehension. A star is born, a new sun blazing to life in the cosmic darkness, sending its light out into the universe for the first time, and from this moment forward, the star will burn, fusing hydrogen into helium in its core, balancing the inward pull of its own gravity against the outward pressure of the energy it generates, maintaining this delicate equilibrium for millions or billions of years depending on its size. Smaller stars burn slowly and steadily, their fuel lasting for tens of billions of years. Our own sun is a medium-sized star, expected to burn for about 10 billion years in total, which means it is roughly halfway through its life. But larger stars, stars with more mass and more gravitational pressure, burn much faster. They are like cosmic bonfires, blazing brilliantly but briefly, consuming their fuel in mere millions of years rather than billions. And it is these larger stars, along with medium-sized stars like our Sun, that eventually become red giants. When a star has fused most of the hydrogen in its core into helium, when the fuel that has sustained it for so long begins to run low, something remarkable happens. The core contracts under its own gravity, growing hotter and denser, while the outer layers of the star expand outward, cooling as they go. The star swells to enormous size, its surface temperature dropping until it glows with that characteristic deep red color that gives red giants their name. This transformation is not sudden. It takes millions of years, a slow and gradual process of expansion and cooling that turns a yellow or white star into a crimson giant. And during this time, the star continues to burn, but in a different way. The helium that accumulated in the core during the star's main sequence life begins to fuse into heavier elements, carbon and oxygen and beyond, releasing energy that keeps the star shining even as it approaches the end of its life. This is the red giant phase, a period of stellar old age that can last for hundreds of millions of years, during which the star is larger and more luminous than it ever was before, but also cooler and more diffuse, its outer layers so thin that they are barely distinguishable from the vacuum of space around them. And it is during this phase, this long twilight of stellar existence, that the mysterious dimming begins. Astronomers first noticed it decades ago, when they were carefully monitoring the brightness of red giants over time. They expected these stars to shine with a certain steady luminosity, determined by their size and temperature and distance. But what they observed was different. The red giants flickered. They dimmed and brightened in irregular patterns that could not be explained by simple physics. Something was interfering with their light, something that seemed to come and go, something that grew more pronounced as the stars aged and approached their final transformation. For years, this dimming remained a mystery, a puzzle that astronomers could observe but not explain, a secret that the red giants seemed determined to keep. Perhaps you're still with me, drifting somewhere between wakefulness and sleep, your mind wandering through these cosmic spaces as your body relaxes more and more deeply. I hope you're finding this journey peaceful, finding comfort in the vast timescales and distances we're exploring, finding a sense of perspective that makes the concerns of daily life seem small and manageable. Because that is part of the magic of astronomy, part of the gift that the cosmos offers to those who take the time to contemplate it. When we think about stars that have burned for billions of years, when we consider distances so vast that light itself takes thousands of years to cross them, our own troubles seem less overwhelming. We are part of something much larger than ourselves, something ancient and ongoing and beautiful, and there is peace in that knowledge, peace in knowing that the universe will continue its slow dance of transformation long after we're gone, just as it was dancing long before we arrived. The mystery of the dimming red giants remained unsolved for decades, a tantalizing question that astronomers could not quite answer. Various theories were proposed over the years, each one attempting to explain why these stellar elders would grow fainter as they approached their end. Some suggested that the dimming was caused by changes in the stars themselves, perhaps fluctuations in their internal structure or variations in their energy output. Others proposed that something external might be responsible, perhaps clouds of interstellar dust drifting between us and the stars, blocking some of their light. But none of these explanations quite fit the observations. The dimming was too regular to be caused by random interstellar clouds, too irregular to be caused by simple internal changes. Something else was happening, something that seemed to be connected to the stars themselves but was not simply a matter of their internal physics. And then, slowly, over years of careful observation and analysis, the answer began to emerge. Astronomers using increasingly sensitive instruments, including space telescopes that could observe wavelengths of light invisible from Earth's surface, began to notice something strange around the dimming red giants. There was material there, vast clouds of gas and dust that seemed to be emanating from the stars themselves, drifting outward into space and partially obscuring the stellar light. This material was not interstellar dust that happened to be passing by. It was stellar dust, material that the red giants were producing and releasing, exhaling into the void as they approached their final transformation. The dimming was not something happening to the stars. It was something the stars were doing actively and continuously as part of their natural evolution. This discovery changed everything. It revealed that the dimming of red giants was not a sign of weakness or decay, but rather a sign of transformation, of the star beginning to release material that would eventually form a planetary nebula, that beautiful glowing shell of gas that marks the death of a sun-like star. The dust clouds that dim the red giants are the early stages of this process, the first exhalations of a star that is preparing to shed its outer layers entirely. And there is something deeply poetic about this, something that feels almost intentional, as if the stars know what is coming and are preparing themselves for it, wrapping themselves in veils of their own creation as they approach their final moment. I want you to consider, as you lie there in the darkness, what it might feel like to be a red giant in these final stages of life. I know this is a strange thing to imagine, perhaps even an impossible thing, but let us try anyway, because there is wisdom in attempting to empathize with things so different from ourselves. Imagine that you have been burning for billions of years, fusing hydrogen into helium and helium into heavier elements, sending your light out into the universe in all directions, warming planets that orbit around you and illuminating the darkness of space. Imagine that you have witnessed the formation of solar systems, the evolution of life, the rise and fall of civilizations that you never knew existed, but that depended on your light for their survival. Imagine that you have been a constant presence in your corner of the galaxy for longer than most species have existed, longer than most planets have been solid, longer than almost anything else in your vicinity. And now imagine that you feel yourself changing. Your core is contracting, growing hotter and denser, while your outer layers are expanding outward, growing cooler and more diffuse. You are becoming something new, something larger and redder and more magnificent than you ever were before. But you're also approaching the end of your existence as a star. You can feel the transformation coming, the moment when you will release your outer layers entirely, scattering them across space in a beautiful expanding shell that will glow with the light of your exposed core. And as this moment approaches, you begin to breathe out, releasing clouds of dust and gas that drift away from you like seeds from a dandelion, carrying the elements you have forged in your heart out into the cosmos, where they might someday become part of new stars, new planets, new forms of life. This is what the red giants are doing when they dim. They are breathing out, releasing material that partially obscures their own light, preparing for the transformation that awaits them. And there is something beautiful about this, something that feels less like death and more like metamorphosis, like a caterpillar dissolving inside its cocoon in order to become a butterfly. The dimming is not an ending. It is a transition, a passage from one form of existence to another, and the dust that causes it is not waste or debris, but rather the raw material for future creation. Every atom that drifts away from a dimming red giant has the potential to become part of something new, something that could not exist without the star's death and transformation. Perhaps you're feeling very relaxed now, very peaceful, your thoughts drifting like those clouds of stellar dust through the vast, quiet darkness of interstellar space. I hope so. I hope you are finding comfort in these cosmic meditations, finding rest in the contemplation of processes so vast and ancient that they make our daily concerns seem small and temporary, because that is one of the gifts that the universe offers us, if we are willing to receive it. Perspective, a sense of scale, a reminder that we are part of something much larger than ourselves, something that was unfolding long before we arrived and will continue unfolding long after we're gone. And there is peace in that knowledge, peace in surrendering our illusion of control and accepting our place in the cosmic order. The red giants teach us this lesson in their dimming. They show us that endings can be graceful, that transformation can be beautiful, that letting go of what we were can be the necessary first step toward becoming what we are meant to be. When a red giant dims, it is not fighting against its fate, it is embracing it, participating actively in its own transformation, breathing out the material that will scatter its essence across the universe. And perhaps there is something we can learn from this, something about how to approach our own transitions, our own endings, our own moments of letting go. Perhaps we can learn to dim gracefully, to release what we have been holding on to trust that what comes next will be beautiful even if we cannot fully imagine it. Let us pause for a moment here, in this space between wakefulness and sleep, and simply contemplate the red giants. Somewhere in the night sky above you, whether you can see it or not, there are red giants shining their ancient light toward Earth. Some of them are dimming right now, breathing out clouds of dust that partially obscure their radiance, preparing for transformations that will take millions of years to complete. Their light has been traveling toward you for centuries or millennia, crossing the vast emptiness of interstellar space at the fastest speed the universe allows, and it is reaching your planet right now, at this very moment, even as you lie there drifting towards sleep. You are connected to these stars in ways both literal and metaphorical. The light that left them long before you were born is touching your world tonight, and the atoms in your body were forged in stars just like them billions of years ago. This connection is real. It is not poetry or metaphor, though it sounds like both. It is simple, beautiful, scientific fact. We are made of star stuff, as Carl Sagan famously said, and the red giants are part of our cosmic family, distant relatives whose lives and deaths have made our existence possible. When you look at a red giant, you are looking at your own origin, your own ancestry, the source of the very atoms that allow you to see and think and wonder. And when a red giant dims, when it breathes out clouds of dust that will someday become part of new stars and new planets, and perhaps new forms of life, it is continuing a process that created you, a process that will continue long after you're gone, a process that connects all living things to the vast and ancient cosmos we inhabit. Now, as we continue our journey through the mystery of the dimming red giants, I want to explore more deeply what astronomers have learned about these stellar exhalations, these clouds of dust that transform the twilight of a star's life into something mysterious and beautiful. Because the more we understand about this process, the more wondrous it becomes, the more it reveals about the intricate connections between stellar death and cosmic creation. And so, let us dive deeper into the science, but gently, without rushing, allowing the knowledge to wash over us like starlight filtering through those very clouds of dust we're discussing. The dust that red giants produce is not like the dust you might find under your bed or on a forgotten shelf. It is something far more exotic, far more interesting, a substance created in conditions that exist nowhere on Earth and nowhere in our solar system. This stellar dust is made of tiny particles, often smaller than a single micron, composed of elements that were forged in the star's core and carried to its surface by complex convection currents. Carbon, oxygen, silicon, magnesium, and many other elements combine in the relatively cool outer atmosphere of the red giant to form solid grains, microscopic seeds that are then pushed outward by the gentle pressure of the star's own light. This process is called stellar wind, and in red giants it becomes particularly powerful, carrying enormous amounts of material away from the star and into the surrounding space. The amount of material that red giants lose through this process is truly staggering. Some of them shed the equivalent of Earth's mass every few thousand years, a rate of loss that seems catastrophic until you remember that these stars contain hundreds of thousands of Earth masses worth of material. They can afford to be generous, to breathe out vast quantities of dust and gas without significantly diminishing themselves, at least for a while. But over millions of years, this loss adds up. The red giant grows smaller and smaller, its outer layers drifting away into space, until eventually only the dense, hot core remains, a white dwarf that will slowly cool over billions of years, fading from view but never quite disappearing, a stellar ember that will persist for longer than the current age of the universe. And the dust. What happens to the dust? It drifts outward from the star, cooling as it goes, forming a vast shell or halo that can extend for light years in every direction. This is the material that causes the dimming. this expanding cloud of stellar exhaust that partially blocks the light of the star that produced it. But the dust does not simply disappear. It continues to drift through the galaxy, carried by the slow currents of interstellar space, mixing with other material from other stars, contributing to the vast reservoir of gas and dust that fills the space between the stars. And eventually, millions or billions of years later, some of this dust will be swept up into a new nebula, a new stellar nursery, where it will become part of a new generation of stars and planets. This is the cosmic cycle, the great wheel of stellar death and rebirth that has been turning since the first stars formed in the early universe. Every atom in your body has been through this cycle at least once, and probably many times. The carbon in your cells was forged in the core of a red giant and breathed out into space in a cloud of stellar dust. The oxygen you're breathing right now was created in the final stages of stellar fusion and scattered across the galaxy by the death of an ancient sun. You're not merely observing this process from a distance, you're a product of it, a temporary arrangement of atoms that have been cycling through stars and planets for billions of years. When you look at a dimming red giant, you're looking at the source of your own existence, the cosmic factory that manufactured the raw materials from which you were eventually assembled. Perhaps this thought is settling into you now, sinking into your consciousness as you drift closer and closer to sleep. Perhaps you can feel the connection, the deep and ancient bond between your body and the stars, between your breath and the stellar winds, between your existence and the cosmic cycle of death and rebirth. There is something profoundly comforting about this connection, something that makes death seem less final and endings seem less absolute. Nothing truly disappears in this universe. Everything transforms. The atoms that make up your body will continue to exist long after you're gone, cycling through other forms, other configurations, perhaps other living things, perhaps other stars. You're part of something eternal, something that began long before you and will continue long after you. And there is peace in that knowledge, peace in being part of something so much larger than yourself. The astronomers who study red giants and their dimming have made remarkable progress in recent years, using increasingly sophisticated instruments to peer into the dusty veils that surround these stellar elders. Space telescopes like the Hubble and the James Webb have captured stunning images of red giants in various stages of their transformation, revealing the complex structures of the dust clouds they produce, the asymmetries and irregularities that make each stellar death unique. Ground-based telescopes equipped with adaptive optics have peered through Earth's atmosphere to resolve details invisible to earlier generations of astronomers, and radio telescopes have detected the molecules that form in these dusty outflows, complex chemical compounds that provide clues about the conditions in which stellar dust forms and evolves. What these observations have revealed is that the dimming of red giants is not a simple, uniform process. Each star dims in its own way, following its own pattern, responding to its own unique combination of mass and age and chemical composition. Some red giants dim gradually and steadily, their dust production increasing slowly over millions of years as they approach their final transformation. Others dim in fits and starts, producing bursts of dust followed by periods of relative clarity, their light fluctuating in irregular rhythms that astronomers are still working to understand. And some red giants produce such thick clouds of dust that they essentially disappear from visible view entirely, their light absorbed and re-emitted at infrared wavelengths, making them invisible to the naked eye but brilliant in the view of infrared telescopes. This diversity is part of what makes the study of red giants so fascinating. Each one is an individual, a unique expression of the cosmic processes that govern stellar evolution. And yet, underlying this diversity, there are common patterns, universal truths about how stars age and transform that apply regardless of the specific details. All red giants eventually dim. All of them produce dust. All of them breathe out material that will contribute to the cosmic cycle of creation and destruction. The differences are in the details, in the timing and intensity and composition of their exhalations, but the fundamental process is the same, a beautiful and inevitable transformation that connects all stars of a certain type across the entire observable universe. Let your mind drift now to one of these individual red giants, a specific star somewhere in our galaxy that is dimming right now, at this very moment, as you lie there listening to these words. Perhaps it is a star that no astronomer has ever named, an anonymous point of light lost among the billions of stars in the Milky Way, dimming and transforming without any witness except the cold void of space around it. Or perhaps it is one of the famous red giants, the ones that humans have observed for centuries that have been named and catalogued and studied by generations of astronomers. It does not matter which one you imagine. What matters is the reality of it, the fact that somewhere in the cosmos, a star that has burned for billions of years is breathing out clouds of dust, dimming its ancient light, preparing for a transformation that will scatter its essence across the galaxy. Can you imagine what it must be like to be that star, to have existed for so long, to have witnessed so much, to have been a constant presence in your corner of the universe for eons, and now to feel yourself changing, transforming, becoming something new? There would be no fear in it, I think, no resistance or regret. Stars do not experience such emotions as far as we know. But there would be a kind of inevitability, a sense of participation in something larger than oneself, a surrender to the cosmic processes that govern all things. And perhaps there is something we can learn from this, something about acceptance and transformation, something about letting go of what we were in order to become what we might be. I want to tell you now about some specific red giants, stars that you might have seen with your own eyes, stars that have been companions to humanity for as long as we have been looking up at the night sky. Because these are not abstractions, not hypothetical objects in distant corners of the universe. They are real, they are visible, and they are dimming right now, following the same process we have been discussing, breathing out clouds of dust that partially veil their ancient light. And knowing about them, being able to look up at the sky and identify them, creates a connection between the abstract science we have been discussing and the concrete reality of the cosmos above our heads. But before we meet these stellar elders by name, before we explore their individual stories and their unique characteristics, I want to pause and invite you to settle even more deeply into this experience. We have been journeying together through the cosmos for some time now, exploring the mystery of why red giants dim before their death, and I hope you have found the journey peaceful and enlightening. I hope you have felt your body relaxing, your breathing slowing, your mind drifting into that quiet space between wakefulness and sleep, where wonders seem possible and mysteries seem less like problems to be solved, and more like gifts to be appreciated. Because that is the spirit in which I want to continue, the spirit in which I want to introduce you to these magnificent stellar elders who are right now preparing for their final transformation. The night sky is full of red giants, but some are more prominent than others, more easily visible, more likely to catch your eye when you look up at the darkness above. And among these prominent red giants, perhaps the most famous is Betelgeuse, the bright reddish star that marks the shoulder of Orion, the Hunter constellation that dominates the winter sky in the northern hemisphere. Betelgeuse is a supergiant actually, a star even larger and more luminous than a typical red giant, but it undergoes the same processes we have been discussing, the same dimming and dust production, the same breathing out of material into the cosmos. And in recent years, Betelgeuse has captured the attention of astronomers and the public alike, because of a dramatic dimming event that seemed to suggest the star might be approaching its final moments. In late 2019 and early 2020, Betelgeuse dimmed significantly, fading to less than half its normal brightness over a period of a few months. For a while, there was speculation that the star might be about to explode, that we might be witnessing the prelude to a supernova that would briefly outshine the entire galaxy, but this turned out not to be the case. Careful observations revealed that the dimming was caused by a combination of factors, including the star's natural pulsation cycle and a large cloud of dust that had been ejected from its surface and was partially blocking our view. Betelgeuse was not dying, at least not imminently. It was simply doing what red giants and supergiants do, breathing out material, dimming temporarily, participating in the cosmic cycle of transformation that we've been exploring tonight. This event was a beautiful illustration of the science we have been discussing, a real-world example of stellar dimming that captured public attention and sparked wonder about the nature of stars and their evolution. And it reminded us that the cosmos is not a static backdrop, not an unchanging ceiling of fixed lights, but a dynamic and evolving system where things are constantly changing, constantly transforming, constantly becoming something new. Betelgeuse will eventually explode, becoming a supernova that will be visible from Earth even in daylight. But that event is still thousands or millions of years in the future, and until then, the star will continue to dim and brighten, breathe out dust, and then clear, pulsating through its long twilight like a cosmic heartbeat. Another famous red giant is Antares, the bright reddish star that marks the heart of Scorpius, the Scorpion constellation that dominates the summer sky in the northern hemisphere. Antares is often compared to Betelgeuse, and for good reason. Both are massive, luminous supergiants at the end of their lives, both a distinctive red colour, both are easily visible to the naked eye. Antares is slightly more distant than Betelgeuse, about 600 light-years away compared to Betelgeuse's approximately 700 light-years. But it is equally impressive, a star so large that if it were placed at the centre of our solar system, its surface would extend beyond the orbit of Mars. Like Betelgeuse, Antares is producing dust, dimming periodically, preparing for a transformation that will eventually scatter its essence across hundreds of light-years of space. And there are many others, too many to name individually, scattered across the night sky like crimson jewels against the black velvet of space. Arcturus in the constellation Bootes, Aldebaran in the eye of Taurus the Bull, Gamma Crucis in the Southern Cross, Gacrux to those who know it well. Each of these stars is a red giant in the twilight of its existence. Each one is breathing out dust. Each one is preparing for the final transformation that awaits all stars of a certain type. When you look up at the night sky, you're looking at a cemetery and a nursery simultaneously, at stars that are dying and stars that are being born, at the cosmic cycle of death and rebirth that has been turning since the beginning of time. Perhaps you will look up at these stars differently now, knowing what you know about their dimming and their transformation. Perhaps you will see them not just as points of light, but as ancient beings preparing for metamorphosis, as stellar elders breathing out the material that will someday become part of new stars and new planets, and perhaps new forms of life. Perhaps you will feel connected to them in a way you did not before, knowing that the atoms in your body were forged in stars just like them, that your very existence depends on the deaths and transformations of countless suns over billions of years. This connection is real and profound, a bond that links you to the cosmos in ways that transcend mere observation, that make you a participant in the great cosmic drama, rather than merely an audience member. As you drift further towards sleep, I want you to carry this connection with you, to let it settle into your consciousness like starlight settling into the darkness of space. You are part of this universe, not separate from it. You are made of the same material as the stars, forged in the same cosmic processes, subject to the same laws of physics and chemistry that govern everything from atoms to galaxies. And when you sleep, when you surrender your waking consciousness to the mysteries of dreams, you are participating in a transformation not entirely unlike the transformation of the red giants. You are letting go of your daytime self, releasing your grip on the waking world, allowing yourself to become something different, something more diffuse and dreamlike, before eventually returning to wakefulness once more. The red giants teach us that transformation is not to be feared. They show us that endings can be beautiful, that letting go can be graceful, that what comes after can be even more magnificent than what came before. When a red giant finally releases its outer layers entirely, when the dust and gas that have been dimming its light disperse into a glowing planetary nebula, the result is one of the most beautiful objects in the universe. Planetary nebulae come in an astonishing variety of shapes and colours, rings and bubbles and hourglasses of glowing gas, illuminated from within by the hot core of the star that created them. They are cosmic art, natural masterpieces painted on the canvas of space by the deaths of ancient suns, and the white dwarf that remains at the centre of each planetary nebula, the dense hot core that is all that is left of the once mighty star, this too is beautiful in its own way. White dwarfs are among the most stable objects in the universe, slowly cooling over billions of years, but never quite going out, persisting as stellar embers for longer than the current age of the cosmos. They are monuments to the stars that created them, small but significant markers of lives that burned for billions of years before finally transforming into something new. Perhaps you're very close to sleep now, your thoughts drifting like that stellar dust through the quiet darkness of your own inner space. Perhaps the words are becoming less distinct, blurring together into a gentle murmur that accompanies you on your journey into dreams. If so, that is perfectly fine. That is exactly what this experience is designed to do, to carry you gently from wakefulness into sleep, to fill your mind with cosmic wonder as you drift across the boundary between consciousness and unconsciousness. The red giants will still be there when you wake, dimming and transforming, breathing out their essence into the cosmos. The mystery will still be there, beautiful and profound, waiting for you to contemplate it again whenever you're ready. But if you're still awake, still listening, still traveling with me through these cosmic spaces, then let us continue our exploration. There is more to discover, more to wonder about, more to learn about the dimming of red giants and what it means for our understanding of the universe. And I am grateful for your company on this journey, grateful for the opportunity to share these cosmic meditations with you, grateful that we can explore these mysteries together in the quiet intimacy of the night. The discovery of why red giants dim before their death is relatively recent, the culmination of decades of observation and analysis by astronomers around the world. But like all scientific discoveries, it raises as many questions as it answers, opening up new avenues of investigation and revealing new mysteries to explore. For example, astronomers are still working to understand exactly how the dust forms in the outer atmospheres of red giants, what chemical processes are responsible for creating these tiny particles that will eventually become part of new stars and planets. They are studying the complex convection patterns that carry heavy elements from the stellar core to the surface, where they can cool and condense into solid grains. They are modeling the stellar winds that push these grains outward into space, trying to understand why some stars lose mass faster than others, why some produce more dust, why the dimming patterns vary so much from star to star. These are technical questions that require sophisticated instruments and complex mathematical models to address, but they are also questions that touch on the deepest mysteries of cosmic creation and transformation. How does a star become a planet? How does stellar material become the stuff of life? How does the death of one thing become the birth of something new? These are the questions that astronomers are grappling with when they study the dimming of red giants, and they are questions that have implications far beyond the narrow realm of stellar astrophysics. They are questions about the nature of the universe itself, about the processes that have shaped everything we see around us, including ourselves. And perhaps the most profound implication of all is the one we have already touched on, the fact that we are made of this material, that the atoms in our bodies were forged in stars and scattered through space by exactly the kind of processes we have been discussing. This is not a new idea, of course. Scientists have known for decades that the heavier elements in our bodies were created in stars, and the phrase, "we are made of star stuff," has become something of a cliché. But knowing something intellectually and truly feeling it are two different things, and I hope that our journey tonight has helped you feel this connection more deeply, more viscerally, more personally than you might have before. When you look at a dimming red giant, you are looking at the source of your own existence. You're witnessing a process that billions of years ago created the very atoms that now allow you to see and think and wonder. You're connected to that distant star in a way that is both literal and profound, a connection that transcends the vast distances of space and the long stretches of cosmic time. And when you sleep tonight, when you close your eyes and surrender your waking consciousness to the mysteries of dreams, you will be doing so in a universe that is constantly creating and transforming, constantly birthing new stars and scattering the remains of old ones, constantly cycling material through endless configurations of matter and energy. This is the cosmic context in which we live, the vast and ancient drama of which we are a small but significant part. And there is something deeply comforting about this context, something that makes our individual lives feel more meaningful, not less. We are not alone in this universe. We are not separate from it. We are expressions of it, temporary arrangements of cosmic material that has been cycling through stars and planets for billions of years. And when our own brief lives end, when our own bodies return to the earth from which they came, the atoms that made us up will continue to exist, cycling through other forms, other configurations, perhaps eventually becoming part of new stars, new planets, new forms of life. But I'm getting ahead of myself again, drifting into contemplations of endings when there is still so much to explore about the journey itself. Let us return to the red giants and their dimming, to the specific details of this beautiful process that we have been discussing. Because the more we understand about how stars transform at the end of their lives, the more we can appreciate the profound connections between stellar death and cosmic creation, between the dimming of distant suns and the existence of everything we know and love. One of the most fascinating aspects of the dust produced by red giants is its chemical composition. As we mentioned earlier, this dust is made of elements that were forged in the star's core and carried to its surface by convection currents. But the specific elements that form dust depend on the chemical makeup of the star, which in turn depends on the star's mass and age and the history of nuclear fusion in its core. Some red giants produce dust that is rich in carbon, dark material that is chemically similar to soot or graphite. Others produce dust that is rich in oxygen, silicate minerals similar to the rocks and sands we find on Earth. And still others produce a mixture of both, complex combinations of carbon and oxygen compounds that form in the relatively cool outer atmospheres of these stellar elders. This chemical diversity has important implications for the cosmic cycle of creation. Carbon-rich dust and oxygen. Rich dust behave differently as they drift through interstellar space. They have different optical properties, absorbing and scattering light in different ways. They have different chemical reactivity, participating in different kinds of molecular synthesis in the cold depths of interstellar clouds, and when they eventually become incorporated into new stars and planets, they contribute different elements to the cosmic mix, different raw materials for the formation of worlds and life. The diversity of dust produced by red giants is one of the reasons why the universe is so chemically rich, why there are so many different kinds of planets and so many different potential pathways for the development of life. Consider for a moment the carbon-rich dust produced by some red giants. This material, once it drifts into interstellar space, can participate in complex chemical reactions that produce organic molecules, the building blocks of life as we know it. Scientists have detected a remarkable variety of organic compounds in interstellar clouds, including amino acids, the basic units from which proteins are built. These molecules formed in the cold darkness of space, far from any planet, far from any living thing, and yet they are the same kinds of molecules that are essential for life on Earth. The connection between stellar dust and biological chemistry is one of the most tantalizing aspects of astrobiology, suggesting that the raw materials for life are produced naturally by the deaths of stars and scattered throughout the galaxy, and oxygen-rich dust has its own important role to play. The silicate minerals that form in the atmospheres of some red giants are chemically similar to the rocks that make up terrestrial planets like Earth. When this dust is incorporated into protoplanetary disks around young stars, it can clump together to form planetesimals, the building blocks of planets, eventually growing into worlds with solid surfaces and complex geologies. The mountains and valleys of Earth, the sandy beaches and rocky coastlines, the very ground beneath your feet, all of this is made of material that was once dust drifting through interstellar space, material that was breathed out by red giants billions of years ago and eventually swept up into the formation of our solar system. This is the profound connection that I keep returning to, the link between stellar dust and everything we know. It is not a metaphor or a poetic fancy. It is the literal truth of how our universe works. The deaths of stars are the births of planets. The exhalations of red giants are the raw materials for new worlds. And we, with our carbon-based chemistry and our mineral bones, are direct descendants of stars that died long before our sun was born, inheritors of a cosmic legacy that stretches back billions of years. Perhaps you're feeling very peaceful now, very connected to this vast and ancient universe that has produced you and everything you love. I hope so. I hope that the contemplation of these cosmic truths is helping you relax, helping you let go of the tensions of the day, helping you drift toward the restorative sleep that your body and mind require. Because there is something healing about this kind of contemplation, something that puts our individual concerns in perspective and reminds us that we are part of something much larger than ourselves. The red giants do not worry about their dimming. They do not fear their transformation. They simply participate in the cosmic process, breathing out dust, releasing their outer layers, preparing for the next stage of their existence with what can only be called grace. And perhaps we can learn something from them. Something about acceptance and surrender. Something about letting go of what we were in order to become what we might be. Sleep itself is a kind of transformation, a daily death and rebirth of consciousness, a letting go of the waking self so that the dreaming self can emerge. And just as the dimming of red giants is not an ending but a transition, so too is sleep not an ending but a passage, a journey from one state of being to another. As we move deeper into this night, deeper into this meditation on the dimming of red giants, I want to explore some of the specific observations that have contributed to our understanding of this phenomenon, because the story of how scientists discovered the truth about stellar dimming is itself a beautiful tale of patience and persistence, of technological innovation and international collaboration, of the slow accumulation of knowledge over decades of careful work. And there is something inspiring about this story, something that reminds us of the power of human curiosity and the rewards of sustained attention to the mysteries of the universe. The study of stellar variability, the field that includes research on the dimming of red giants, has a long and distinguished history. For centuries, astronomers have been tracking the changes in brightness of various stars, noting which ones vary and by how much, trying to understand the physical processes responsible for these variations. Early observers did this work with the naked eye, comparing the brightness of variable stars to nearby constant stars and recording their estimates in notebooks that have survived to the present day. Later generations used telescopes and photographic plates, then electronic detectors, each new technology allowing more precise measurements and revealing previously undetectable variations. The red giants presented a particular challenge to these observers because their variations are often slow and subtle, playing out over months or years rather than days or weeks. It takes patience to study such stars, the willingness to return night after night, year after year, building up a record of observations that can reveal patterns invisible in any single session. And even with such patient observation, the variations of red giants remained puzzling for a long time. They did not follow simple, predictable patterns like some other variable stars. They seemed to brighten and dim in irregular ways, their light curves messy and complex, defying easy explanation. The breakthrough came when astronomers began to combine their observations with theoretical models of stellar evolution and mass loss. They realized that the irregular variations of red giants could be explained by the ejection of dust into the stellar atmosphere, material that formed in cool regions near the star's surface and then drifted outward, partially blocking the star's light before dispersing into space. This explanation fit the observations beautifully, accounting for both the dimming events and the eventual return to normal brightness. The red giants were not changing in some fundamental way. They were simply shrouding themselves temporarily in veils of their own creation, breathing out dust that would eventually clear, only to be replaced by new dust in an ongoing cycle of exhalation and dissipation. This understanding was refined over the following decades as new technologies allowed more detailed observations. Infrared telescopes, which can detect the heat radiation emitted by warm dust, revealed the extensive dust shell surrounding many red giants, confirming that these stars were indeed ejecting significant amounts of material into space. Spectroscopic observations allowed astronomers to identify the specific chemical compounds in this dust, mapping the complex chemistry of stellar atmospheres, and interferometric techniques, which combine the light from multiple telescopes to achieve extremely high resolution, allowed astronomers to image the dust shells directly, seeing for the first time the structures that had been causing the dimming events. One of the most important contributions to our understanding came from space-based observatories, which can observe wavelengths of light that are blocked by Earth's atmosphere. The Hubble Space Telescope, launched in 1990, has produced countless images of red giants and their surrounding dust structures. The Spitzer Space Telescope, which operated from 2003 to 2020, was particularly valuable for studying stellar dust because it observed in the infrared, the wavelengths where warm dust radiates most strongly, and the James Webb Space Telescope, launched in 2021, has taken our observations to an entirely new level of detail and sensitivity, revealing structures in stellar dust shells that were previously invisible. These observations have confirmed and extended the basic picture that emerged from earlier studies. Red giants do indeed breathe out vast quantities of dust as they approach the end of their lives. This dust partially obscures their light, causing the dimming events that astronomers have been tracking for decades, and the dust eventually disperses into interstellar space, contributing to the raw materials from which new stars and planets will someday form. The mystery of the dimming red giants has been solved, at least in its broad outlines, though many details remain to be worked out. But perhaps more important than the specific scientific findings is the sense of wonder that this discovery evokes. When we look at a dimming red giant, we are witnessing a cosmic process that connects stellar death to planetary birth, that links the endings of ancient suns to the beginnings of new worlds. We are seeing the universe in the act of transformation, the endless cycle of creation and destruction that has been operating since the first stars formed and will continue to operate long after our own sun has run its course. And there is something profoundly moving about this, something that transcends the technical details and speaks to our deepest intuitions about the nature of existence. If you're still here, still listening, still traveling with me through these cosmic spaces, I invite you to pause for a moment and reflect on what we have explored together. We have journeyed from the familiar warmth of our own sun to the distant reaches of the galaxy where red giants are dimming and transforming. We have learned about the dust that veils their light and the cosmic cycle that recycles their material into new stars and planets. We have contemplated our own connection to these stellar elders, the fact that we are made of the same stuff, forged in the same cosmic fires, subject to the same processes of transformation. If any of this has resonated with you, if any of it has sparked wonder or curiosity or a sense of connection to the larger universe, I would love to hear about it. Please leave a comment below and share what you have found most interesting, what thoughts or feelings this journey has evoked in you. Your reflections enrich this experience for everyone, creating a community of cosmic contemplators who share in the wonder of the universe. And now, as we continue our journey, let us turn our attention to the deeper implications of what we have learned, because the dimming of red giants is not just an interesting astronomical phenomenon. It is a window into the fundamental processes that have shaped our universe and made our existence possible. And contemplating these processes can change the way we see ourselves and our place in the cosmos, can give us a sense of perspective and connection that is both humbling and uplifting. Consider the fact that everything you see around you, every object and substance and living thing, is made of atoms that were created in stars. The carbon in your cells, the oxygen in your blood, the calcium in your bones, the iron that carries oxygen through your body, all of these were forged in stellar cores and scattered through space by the deaths of suns. You're not merely an observer of the cosmic process, you're a product of it, a temporary arrangement of ancient atoms that have been cycling through the universe for billions of years. When you breathe, you are participating in the same exchange of matter that occurs on a cosmic scale, taking in atoms that have passed through countless other forms and releasing atoms that will pass through countless more. This perspective can be disorienting at first. It can make us feel small and insignificant, adrift in a universe so vast that our existence seems to matter not at all. But I would suggest a different interpretation, one that finds meaning and significance precisely in this cosmic connection. We are not separate from the universe. We are expressions of it, the universe becoming conscious of itself, the cosmos contemplating its own nature through our wondering eyes. When you look at a red giant and ponder its dimming, you are the universe looking at itself, matter arranged in such a way that it can observe and understand and appreciate the very processes that created it. This is perhaps the most profound implication of all, the idea that consciousness itself is a cosmic phenomenon, an emergent property of matter that has been cycling through stars and planets for billions of years. We do not know how consciousness arises, what specific arrangements of atoms give rise to experience and awareness, but we do know that the atoms from which our brains are made were forged in stars, that the complex chemistry of our neural processes depends on elements that could only have been created in stellar cores. In some sense, then, the stars are thinking through us, experiencing the universe through our senses, wondering about their own nature through our minds. And perhaps this is what makes the dimming of red giants so moving, so significant beyond its purely scientific interest. When we contemplate these stellar elders preparing for their final transformation, we're contemplating our own origins and our own eventual return to the cosmic cycle. The atoms in our bodies will one day disperse, just as the atoms of the red giants are dispersing, drifting off into new configurations that may include new stars, new planets, new forms of life. We are not permanent. Nothing is permanent, but we are connected, bound together with everything else in the universe by the fundamental processes that govern matter and energy, by the cosmic cycle of transformation that makes all things possible. Let this thought settle into you as you continue to drift towards sleep. Let it wrap around you like a blanket, comforting you with the knowledge that you are part of something much larger than yourself, something ancient and ongoing and beautiful. The red giants are your ancestors, in a very literal sense. The dust they breathe out is your inheritance, and the transformation they undergo is a preview of the transformation that awaits all things, the endless cycle of death and rebirth that is the heartbeat of the universe. Perhaps you are very close to sleep now, your thoughts fragmenting into dream images, your sense of self beginning to dissolve into the larger awareness that exists beneath our waking consciousness. If so, that is perfect. That is exactly where this journey is meant to take you. The cosmos is a place of wonder and mystery, and sleep is a doorway into that wonder, a nightly opportunity to let go of the constructed self and merge with something larger, something more fundamental. When you dream, you are participating in a process as old as consciousness itself, a process that connects you to every being that has ever dreamed, every mind that has ever wondered, every consciousness that has ever emerged from the cosmic cycle of transformation. But if you are still awake, still present, still traveling with me through these cosmic spaces, then let us continue. There is more to explore, more to wonder about, more to learn about the dimming of red giants and its implications for our understanding of the universe. And I am honoured to have you as a companion on this journey, grateful for the opportunity to share these meditations with someone who is willing to venture into the cosmic darkness in search of light. The process by which red giants produce dust is remarkably complex, involving physics and chemistry that scientists are still working to understand fully. At its heart is the interplay between the star's internal processes and its outer atmosphere, between the nuclear fusion occurring deep in the stellar core and the relatively cool conditions near the surface where dust can form. In a red giant, these two regions are connected by convection, the churning motion of stellar material that carries heat and heavy elements from the core to the surface. This convection is what makes red giants so luminous and so variable, constantly stirring their interiors and affecting the conditions in their outer atmospheres. In the cooler outer layers of a red giant, where temperatures drop to a few thousand degrees, atoms can begin to combine into molecules, the first step toward the formation of solid dust grains. Carbon atoms link up with other carbon atoms, or with oxygen and nitrogen and hydrogen, forming molecules that are similar to some found in flames and exhaust here on Earth. These molecules drift through the stellar atmosphere, cooling as they rise to ever higher levels, eventually reaching temperatures where they can condense into tiny solid particles. And once these particles form, they begin to interact with the star's light, absorbing some wavelengths and scattering others, creating the dimming effect that astronomers observe. The particles themselves are incredibly small, often just a few nanometers across, smaller than the wavelength of visible light. And yet, when they accumulate in sufficient quantities, they can significantly affect the appearance of the star, dimming its light by factors of 2 or 3 or more. This is because even tiny particles can scatter and absorb light very efficiently when there are enough of them, creating a hazy veil that obscures the stellar surface. The effect is similar to what happens when smoke or fog blocks our view of a distant light source here on Earth, though on a vastly larger scale. Once the dust particles form, they are pushed outward by the pressure of the star's light, a phenomenon called radiation pressure. Light carries momentum, and when it is absorbed or scattered by a dust particle, it imparts some of that momentum to the particle, pushing it away from the star. This radiation pressure is quite weak for individual photons, but the sheer number of photons streaming out from a red giant creates a steady outward force that can overcome the star's gravity for small particles. The result is a stellar wind, a continuous flow of dust and gas away from the star and into the surrounding space. This stellar wind from red giants is much stronger than the stellar wind from our Sun or other main sequence stars. While our Sun loses only a tiny fraction of its mass to its stellar wind each year, a red giant can lose a significant fraction of its entire mass over the course of its red giant phase. This is one of the ways that stars contribute material to the interstellar medium, the thin gas and dust that fills the space between stars, and this material, enriched with heavy elements that were forged in the stellar core, will eventually be incorporated into new generations of stars and planets. The images captured by modern telescopes show the beautiful structures created by this mass loss. Around many red giants, Astronomers have observed extended shells and arcs of dusty material, glowing in infrared light as they slowly cool and disperse. Some of these structures are remarkably symmetric, perfect spheres of expanding material centered on the star. Others are highly asymmetric, with jets and streams and irregular clumps that suggest complex internal processes we do not yet fully understand. Each red giant creates its own unique pattern of mass loss, its own signature in the dusty medium surrounding it. These structures can persist for thousands of years after the dust is ejected from the star, slowly expanding and fading as they merge with the general interstellar medium. Eventually, the material disperses to the point where it is no longer detectable as a distinct structure, becoming part of the background of interstellar dust and gas that fills the galaxy. But even then, the atoms retain their identity, their nuclear composition unchanged by the long journey from stellar core to interstellar space. Carbon remains carbon, oxygen remains oxygen, silicon remains silicon, each atom carrying the record of its origin in the heart of a dying star. And someday, millions or billions of years from now, some of these atoms may find themselves caught up in a new cycle of star formation. They may drift into a molecular cloud where gravity is beginning to pull material together. They may be incorporated into a protostellar disk, orbiting a young sun not yet born. They may clump together with other particles to form planetesimals, the building blocks of planets. And eventually, they may become part of a new world, a new ocean, a new atmosphere, perhaps even a new form of life. The cycle continues, endlessly, transforming but never truly ending, carrying material from generation to generation of stars across billions of years of cosmic time. This is the context in which we exist, the vast cycle of cosmic transformation that has been operating since the first stars formed in the early universe. And the dimming of red giants is a window into this cycle, a glimpse of the process by which material is transferred from old stars to the interstellar medium, where new stars will eventually form. When you look at a dimming red giant, you're seeing the universe in the act of recycling itself, transforming old matter into the raw materials for new creation. If you are still here, still listening, I want to take a moment to thank you for your continued presence on this journey. We have traveled far together, from the familiar warmth of our own sun to the distant reaches of the galaxy, where red giants are dimming and transforming. We have explored the science of stellar dust and the cosmic cycle of creation and destruction. We have contemplated our own connection to these processes, the fact that we are made of star stuff and will eventually return to the cosmic cycle from which we came. And through it all, I hope you have found peace and wonder, a sense of connection to the larger universe that makes the concerns of daily life seem small and manageable. Please take a moment to leave a comment below and share what you have found most interesting about this journey. What thoughts or feelings has it evoked? What questions remain in your mind? Your reflections help create a community of cosmic contemplators, and I always love to hear from those who have traveled with me through these meditations on the universe. If you have not already, please consider subscribing to join us for future journeys, future explorations of the mysteries that surround us in this vast and beautiful cosmos. As we continue our exploration, let us turn our attention to one of the most famous examples of stellar dimming in recent memory, an event that captured the attention of astronomers and the public alike, and illustrated many of the principles we have been discussing. I am speaking, of course, of the great dimming of Betelgeuse, the dramatic fading of this famous red supergiant that occurred in late 2019 and early 2020. This event provides a perfect case study of how astronomers investigate stellar dimming and what they can learn from such investigations. Betelgeuse is one of the most prominent stars in the night sky, the bright reddish star that marks the shoulder of Orion in the famous Hunter constellation. It is a red supergiant, even larger and more luminous than a typical red giant, a star approaching the end of its life and destined to explode as a supernova sometime in the next 100,000 years or so. For centuries, astronomers have observed Betelgeuse varying in brightness, sometimes brighter, sometimes fainter, following semi-regular patterns that reflect processes occurring in its extended atmosphere and interior. But in late 2019, something unusual happened. Betelgeuse began to dim more dramatically than usual, fading from its normal brightness of around magnitude 0.4 to magnitude 1.6 by February 2022. This represents a decrease in brightness by a factor of more than 2, a change easily visible to the naked eye and unprecedented in the recorded history of observations of this star. For a few months, Betelgeuse was noticeably fainter than its normal appearance, prompting widespread speculation about what might be happening. The most dramatic speculation was that Betelgeuse might be preparing to explode, that the dimming might be a prelude to the supernova that astronomers know will eventually occur. This idea captured the public imagination, generating news stories and social media posts about the possibility of witnessing a stellar explosion visible in daylight. But astronomers were skeptical from the beginning. The processes leading to a supernova are not expected to cause the kind of surface dimming that was observed, and the timescales involved are much shorter than the thousands of years over which Betelgeuse is expected to explode. Instead, astronomers turn to the explanation we have been discussing throughout this journey: dust. Detailed observations with ground-based and space-based telescopes revealed that the dimming was caused, at least in part, by a large cloud of dust in Betelgeuse's atmosphere that was partially blocking our view of the star. This dust had formed when material ejected from the star's surface cooled to the point where solid particles could condense, creating a veil that dimmed the star's light. The effect was enhanced by the star's natural pulsation cycle, which had recently entered a phase of reduced brightness, combining with the dust obscuration to produce the dramatic dimming that was observed. By April 2020, Betelgeuse had begun to brighten again, and by the middle of that year it had returned to approximately its normal brightness. The great dimming event was over, and Betelgeuse continues to shine in Orion's shoulder as it has for countless generations, still preparing for its eventual explosion, but apparently in no hurry to get there. The event was a beautiful illustration of the processes we have been discussing, a real-world example of how red giants and supergiants dim when they breathe out clouds of dust, and a reminder that the cosmos is dynamic and changing, never quite the same from one moment to the next. What made the great dimming of Betelgeuse particularly valuable for astronomers was the opportunity to observe the event in real time with modern instruments. Telescopes around the world and in space turned their attention to Betelgeuse during the dimming, collecting data across the electromagnetic spectrum that has provided unprecedented insights into the processes occurring in this star's atmosphere. Infrared observations tracked the thermal emission from the dust cloud as it formed and cooled. Spectroscopic observations monitored changes in the star's chemical composition and atmospheric structure. Interferometric observations even managed to image the star's surface directly, revealing the hot and cool regions that drive convection and mass loss. These observations have contributed to a much more detailed understanding of how red supergiants like Betelgeuse produce and expel dust, how this dust affects the star's appearance, and how the material eventually disperses into interstellar space. They have also raised new questions, revealing complexities and subtleties that challenge existing models of stellar mass loss. Science always works this way, with each answer opening new questions, each discovery revealing new mysteries. The great dimming of Betelgeuse was not the end of our exploration, but a new beginning, an invitation to dig deeper into the processes that govern the lives and deaths of the larger stars. And perhaps that is the most important lesson of all, the one that applies not just to astronomy, but to all of our explorations of the world and ourselves. The answers we find are never final. They always lead to new questions, new mysteries, new opportunities for wonder and discovery. The cosmos is inexhaustible, an infinite source of puzzles and marvels that will never run out no matter how long we study them. And there is something deeply comforting about this, something that makes the enterprise of science feel like a journey rather than a destination, a way of engaging with the universe that is its own reward. As you lie there in the darkness, perhaps very close to sleep now, I invite you to embrace this sense of endless possibility. The universe is full of mysteries waiting to be discovered, red giants waiting to be observed, cosmic processes waiting to be understood. And you are part of this universe, connected to it in ways both literal and profound, an expression of the same forces and materials that shape the stars. When you sleep tonight, when you drift into dreams of who knows what, you will still be connected, still part of the cosmic web of matter and energy that has been evolving since the beginning of time. The red giants will continue to dim while you sleep, breathing out their dust, preparing for their transformation. The atoms they release will continue to drift through the galaxy, eventually becoming part of new stars and new planets, and the cosmic cycle will continue, as it has for billions of years, as it will for billions more, carrying material from generation to generation in an endless dance of creation and destruction. Let these thoughts accompany you as you drift deeper into relaxation, deeper into the peace that comes from feeling connected to something larger than yourself. The universe is vast and ancient and full of wonder, and you are part of it, a brief but beautiful expression of the cosmic processes that govern all things. When you dream tonight, perhaps you will dream of red giants and their dusty veils, of stellar nurseries and planetary nebulae, of the endless cycle of transformation that connects all things across space and time. And when you wake tomorrow, the cosmos will still be there, waiting for you to continue your exploration, waiting to reveal new mysteries and new wonders to your wondering eyes. We have journeyed far together tonight, and there is still farther to go. The mystery of the dimming red giants has revealed its secrets to us, but there are always more secrets, always deeper levels of understanding to pursue. In the sections that follow, we will explore the specific chemistry of stellar dust, the role of particular stars like Betelgeuse and Antares in this cosmic story, and the profound implications of stellar dust for the formation of planets and the emergence of life. But for now, let us rest in what we have learned, letting the wonder of it settle into us like starlight settling into the darkness of space. The cosmos is speaking to us through the dimming of red giants, telling us a story about transformation and connection, about endings that are really beginnings, about death that is really just a change of form. And if we listen carefully, if we open ourselves to the message, we can hear in that story something deeply relevant to our own lives, something about acceptance and surrender, about letting go and becoming something new. The red giants do not resist their dimming. They participate in it, actively and gracefully, breathing out the material that will carry their essence into the future. Perhaps we can learn from them, can find in their example a model for our own transformations, our own endings, our own passages from one state of being to another. For now, rest in the peace of cosmic connection. Rest in the knowledge that you are made of star stuff, that your atoms have cycled through the universe for billions of years and will continue to cycle for billions more. Rest in the wonder of a universe that produces such magnificent phenomena as the dimming of red giants, such beautiful processes as the cosmic cycle of creation and destruction. And when you are ready, we will continue our journey together, exploring ever deeper into the mysteries that surround us, finding peace and wonder in the contemplation of the infinite cosmos. The stars are waiting for us, ancient and patient, dimming and transforming as they have for eons. They have secrets still to share, mysteries still to reveal, wonders still to illuminate. And we have the privilege of contemplating them, of being the universe's way of wondering about itself, of carrying forward the cosmic story into whatever comes next. This is our place in the great scheme of things, small but significant, brief but meaningful, connected to everything that has come before and everything that will come after. Let this knowledge carry you now, as we continue our journey through the quiet cosmos, through the dusty veils of dying stars, toward the peaceful rest that awaits at the end of every day, and the new beginnings that await at every dawn. The red giants are dimming, and we are here to witness it, to wonder at it, to find in it the peace and perspective that comes from contemplating the vast and beautiful universe we call home. Now, as we move forward in our journey, I want to take you deeper into the nature of these magnificent stellar elders, to help you understand not just what they are doing, but why. Not just how they dim, but what this dimming means in the larger context of stellar evolution. Because the dimming of red giants is not an isolated phenomenon, not a curious anomaly in an otherwise static universe. It is part of a story, a narrative that begins with the birth of stars in cosmic nurseries and ends with their transformation into something entirely new. And understanding this story, seeing the dimming in its proper context, can deepen our sense of wonder and connection to the cosmos. Every star that becomes a red giant was once something else, something smaller and hotter and more compact. Our own sun, for example, is currently in the prime of its life, a yellow dwarf burning steadily and reliably as it fuses hydrogen into helium in its core. But the sun has not always been this way, and it will not always remain so. Billions of years ago, the sun was a protostar, a collapsing cloud of gas and dust that had not yet ignited nuclear fusion. and billions of years from now, the sun will be a red giant, swollen and crimson, and breathing out dust into the cosmos. The yellow dwarf, we know, is just one phase in a longer journey, one chapter in a story that spans the entire lifetime of the star. This story begins in the molecular clouds that drift through galaxies, vast structures of cold gas and dust where new stars are constantly being born. These clouds are the nurseries of the cosmos, the places where gravity gathers material together and ignites the nuclear fires that will burn for millions or billions of years. Inside these clouds, regions of higher density collapse under their own gravity, pulling in more and more material until the central mass becomes hot and dense enough to initiate nuclear fusion. When this happens, a star is born, blazing to life in the cosmic darkness, sending its first light out into the universe. The young star is surrounded by a disk of leftover material, gas and dust that did not fall into the star itself but instead began orbiting around it. This is a protoplanetary disk, the birthplace of planets, and over millions of years the material in this disk clumps together to form worlds of various sizes and compositions. Some become gas giants like Jupiter and Saturn, accumulating thick atmospheres of hydrogen and helium. Others become rocky worlds like Earth and Mars, building up layers of silicate rock and metal. And some become something in between, ice giants like Uranus and Neptune, or water worlds or super-Earths, or any of the countless variations that astronomers have discovered in planetary systems throughout the galaxy. But while planets are forming in the disk, the star at the center is burning, fusing hydrogen into helium in its core, maintaining the delicate balance between gravity and pressure that allows it to exist. This is the main sequence phase of stellar evolution, the longest and most stable period in a star's life, the time when it shines most steadily and predictably. Our Sun has been in this phase for about 4.5 billion years and will remain there for another 5 billion or so. During this time, it will continue to warm and illuminate the planets that orbit it, providing the energy that makes life possible on at least one of those worlds. But the main sequence cannot last forever. Eventually, the hydrogen in the star's core begins to run low, depleted by billions of years of nuclear fusion. When this happens, the star faces a crisis. The energy that has been supporting it against the crush of gravity begins to falter, and the core contracts, growing hotter and denser as it shrinks. This contraction releases gravitational energy, some of which heats the layers of hydrogen surrounding the core to the point where they can begin fusing as well. Hydrogen burning moves outward from the core in a shell, and the star's structure changes dramatically. As the core contracts and heats up, the outer layers of the star do the opposite. They expand and cool. The star swells to many times its original size, its surface spreading outward until it is tens or hundreds of times larger than it was on the main sequence. This expansion causes the surface to cool, changing its color from yellow or white to orange or red. The star has become a red giant, a stellar elder in the twilight of its existence, magnificent and bloated and very different from the compact hot star it once was. This transformation takes millions of years, a gradual process of expansion and cooling that unfolds over timescales that dwarf human history but are brief by cosmic standards. And during this transformation, the star continues to burn, though in a different way than before. The core, now composed mostly of helium, eventually becomes hot and dense enough to initiate a new kind of nuclear fusion, the fusion of helium into carbon. This process releases energy that partially stabilizes the star, allowing it to burn for hundreds of millions of years more in its red giant phase. But the red giant phase is inherently unstable, much more so than the main sequence. The star pulsates, swelling and shrinking in slow rhythms that can take years to complete. Its surface bubbles with convection, hot material rising from deep within and cool material sinking back down, creating a constantly churning atmosphere. And most importantly for our story, the star begins to lose mass, breathing out material from its extended atmosphere into the surrounding space. This is where the dimming begins, where the dust forms, where the cosmic cycle of transformation that we have been discussing starts to unfold in earnest. The mass loss from red giants is driven by a combination of factors. The extended atmosphere is only loosely bound to the star by gravity, its particles moving at speeds that are not much slower than the escape velocity. Pulsations in the star can push material outward, giving it the extra velocity it needs to escape. And once dust forms in the outer atmosphere, radiation pressure from the star's light pushes on these grains, accelerating them outward and dragging the surrounding gas along with them. The result is a stellar wind, a continuous outflow of material that can strip away a significant fraction of the star's mass over the course of its red giant phase. This is the process that causes the dimming we have been discussing. As dust forms in the stellar atmosphere and is pushed outward by radiation pressure, it creates a hazy veil around the star that partially blocks its light. The dust absorbs some wavelengths and scatters others, reddening and dimming the star's appearance as seen from Earth. And as new dust continuously forms and old dust disperses into space, the star's brightness fluctuates, sometimes dimmer and sometimes brighter, in irregular patterns that reflect the complex dynamics of dust formation and dispersal. For a red giant like the stars we have been discussing, this process can continue for millions of years, gradually stripping away the star's outer layers and reducing its mass. Eventually, so much material has been lost that the star can no longer sustain the nuclear fusion that has kept it burning. The outer layers disperse entirely, forming an expanding shell of glowing gas called a planetary nebula, illuminated by the hot, exposed core of the star. And at the center of this nebula, where the star once burned, a white dwarf remains, a dense, Earth-sized remnant that will slowly cool over billions of years, eventually fading from view, but never quite disappearing. This is the fate that awaits our sun. Billions of years from now, it will swell into a red giant, possibly engulfing the inner planets, including Earth. It will breathe out dust and gas, dimming and fluctuating as it loses mass to the stellar wind. It will shed its outer layers in a beautiful planetary nebula that will glow for tens of thousands of years before dispersing into the interstellar medium, and it will leave behind a white dwarf that will persist for longer than the current age of the universe, a cooling ember marking the place where our star once burned. This fate is not to be mourned. It is simply the next phase in the cosmic cycle, the transformation that allows old material to become part of new creation. The atoms that make up the sun, including those that were part of our Earth and our bodies before being incorporated into the star's outer layers, will be scattered across light years of space. Some will drift for millions of years in the cold darkness between the stars. Some will be swept up into new molecular clouds, new stellar nurseries, where they will become part of new generations of stars and planets, and some, perhaps, will end up in new forms of life on new worlds, distant descendants of the cosmic cycle that produced us. This is the story that the dimming of red giants tells us, the narrative of stellar transformation that connects the deaths of ancient suns to the births of new worlds. When we observe a red giant dimming, when we see its light flickering and fading behind veils of dusty exhaust, we are witnessing a chapter of this story in progress. We are seeing the universe in the act of recycling itself, transforming old matter into new possibilities. And there is something deeply reassuring about this, something that makes death seem less final and endings seem less absolute. Perhaps you are feeling this reassurance now, as you lie there in the darkness, your thoughts drifting towards sleep. Perhaps the contemplation of these cosmic processes has given you a sense of perspective, a feeling of connection to something larger than yourself and your individual concerns. The red giants teach us that transformation is natural, that letting go is part of existence, that endings are just beginnings in disguise. And perhaps, as you drift towards sleep, you can carry this teaching with you, can let it inform your own relationship with endings and transformations, can find in it a source of peace and acceptance. The universe is constantly changing, constantly transforming, constantly becoming something new. Nothing lasts forever, not stars, not planets, not galaxies, not even the universe itself as we currently know it. But this impermanence is not a tragedy. It is the very condition that makes novelty possible, that allows new things to emerge, that gives the cosmos its dynamism and its beauty. If nothing ever changed, nothing new could ever happen. And the changes we observe, including the dimming of red giants, are part of a process that has produced everything we know and love, including ourselves. So rest now in this cosmic perspective, in this knowledge of your connection to the stars and their transformations. Rest in the awareness that you are part of something ancient and ongoing, a cycle that began long before you and will continue long after you are gone. Rest in the peace that comes from accepting impermanence, from embracing change, from seeing endings as transitions rather than terminations. The red giants are dimming, as they have for billions of years, as they will for billions more, and you are here to witness it, to wonder at it, to find in it a message about the nature of existence and your place within it. As we continue our journey through the mystery of the dimming red giants, let us turn now to a closer examination of the dust itself, this remarkable material that veils the light of dying stars and carries stellar essence out into the cosmos. Because the dust is not just an obscuring medium, not just a byproduct of stellar evolution. It is a substance of extraordinary complexity and importance, a bridge between stellar death and planetary birth, a key component in the cosmic chemistry that makes life possible. The dust produced by red giants comes in many varieties, depending on the chemical composition of the star and the conditions in its outer atmosphere. Some stars produce dust that is rich in carbon, dark grains of graphite and amorphous carbon that are chemically similar to soot. These carbon-rich grains form in stars where carbon atoms outnumber oxygen atoms in the outer atmosphere, allowing the carbon to condense into solid particles rather than being locked up in carbon monoxide molecules. Carbon-rich dust is particularly common around certain types of red giants called carbon stars, which have dredged up carbon from their cores to their surfaces through deep convection. Other stars produce dust that is rich in oxygen, silicate minerals similar to olivine and pyroxene that are familiar from terrestrial geology. These oxygen-rich grains form in stars where oxygen atoms outnumber carbon atoms, allowing the oxygen to combine with silicon, magnesium, and iron to form silicate crystals. Oxygen-rich dust is common around the majority of red giants, whose surface composition has not been significantly altered by dredge-up from the core. And some stars produce both types of dust, or mixtures that include additional components like silicon carbide, aluminum oxide, or various forms of ice. The diversity of stellar dust reflects the diversity of stellar evolution, the many different pathways that stars can follow depending on their mass, composition, and history. Each red giant is unique, and the dust it produces is a fingerprint of its individual characteristics,